All right, welcome everybody to the August 19th, 2020 Octant community meeting. Today's agenda is an interesting one. We're going to be covering kind of the direction of where Octant is headed, and kind of summarize that we held a little mini Octant engineering summit early this week, and we wanted to use the community meeting that was on Monday, where we just kind of talked about all these various things about Octant 1.0 and plugins and the Electron app, and so we just wanted to summarize kind of what all that meant, and then I think we'll be talking about the update of moving Octant to Go 1.15, and then there'll be some Q&A after that. So to get started, one of the kind of the overarching idea from the engineering summit was, what does it mean for Octant to be 1.0? And the consensus that we landed on was that the part of Octant that really needs to be versioned is the plugin API. And so Octant 1.0 isn't necessarily any set of specific features. It's more about the plugin API and having that plugin API be an API that we are happy with and one that we are going to be supporting and ensuring is in good condition between versions. So that led to a bigger discussion around plugins and what does the 1.0 API look like, and so we talked about the JavaScript Plugin API and decided that we're going to continue to that initially started off as like an experimental proof of concept. It has since started to be used for plugins and is it's turning out to be a very nice development flow. It does lack in some things that the Go API currently has, but we're going to be putting in some significant engineering investment into the JavaScript Plugin API. A lot of it is around building out better libraries for the TypeScript, like building out better TypeScript definitions and libraries and helpers, building out factories for all the components. Brian Lyles did some work on auto-generating some of these components. And then we're also just going to, increase the kind of the usefulness of the helpers and other things that we have within the JavaScript API on the TypeScript side of things. On the Octant side of things, the actual API that we're used to of like, here's a printer, here's a object status, here's a tab handler, those types of things, those will probably, I think ultimately those are gonna probably have some modifications made to them, but they'll all still feel very much like they feel now. I don't know that they'll change drastically. They may change in a way that breaks plugins, but we will be very sure to note that, help people migrate, ensure there's a path to migrate if we do break things. The reason I'm saying this is because there's some discussion around making sure that the way Octant draws things on the screen, so how it implements its modules and how it implements its describers, uses the same API that plugins use. Right now, we kind of sidestep the plugin API, and we just directly pass in all of the object stores and the WebSocket clients and all those things. We just pass them directly into our describers, and then we build out our view, and then we return a content response, which is exactly what a plugin does when it's running as a module and it builds out a content response. So the reason we want to shift towards making Octant use the same API that plugins are using is because it will ensure a richer set of features becomes available for plugins, and it will enable Octant to then function in a way that you could essentially remove the core view, like you could completely remove the core views from Octant and have only your plugin views if you wanted, something like that. So it provides a lot more flexibility in what plugins will be able to do by us kind of dog fooding that plugin API for our own internal views. Now that said, that means that the Go plugin API will continue to exist. It's not going to go anywhere. It's just we're going to be putting less of an investment in it for the time being, because we really want to get this JavaScript plugin API fully fleshed out and have people kind of moving towards building their plugins in that way. There will still be a Go plugin API. All the existing Go plugins will still compile against it, and that's likely what we are going to use, at least initially internally for Octant, is the Go API for the internal views that will now be written to the plugin API. Now that may change. We may decide that we're just going to go ahead and ship all of our views as JavaScript plugins for Octant. That would be very interesting. I don't know how we would exactly do it. It'd probably involve like a rice box that has our plugins in it, and they get loaded, when Octant starts up. Could be something to that effect. But for now, they'll be done via the Go API. New components that we add will continue to work for both APIs. So you don't have to we're not fully deprecating the Go API for plugins at this point. I don't know. We've talked about it. We might in the far future, but if we're going to, we'll make that decision before 1.0. But as I see it right now, I don't think that's going to happen. I think we're going to have both models in place, and the JavaScript model is going to be kind of a richer ecosystem for external plugins and third-party plugins, and the Go API is just going to be that standard plugin model, that experience that kind of everyone is used to now. The other thing with plugins is we really want to get some form of a web component in place. And what that means is being able to send up your own, you've built out a component, a view, it has diagrams, it has charts, whatever it is, right? Being able to then use that in a view in Octant. Right now, if Octant doesn't have a component baked into it, you either have to do some really, you can do an iframe and hook up your plugin to an external API that does REST calls to to a completely separate service that you load in as an iframe, right? And that's one way to ship data and have it show in Octant, but that's really not convenient. It's not a great pattern. So we would like to enable the ability for plugins to be able to build out this idea of so there's web component. Terms are so overloaded in the world, but there's web components, which are these JavaScript runtimes that can run in a browser as a web component. If you look up web components on the Mozilla, right? But then there's web component, which will be our other Octant components, which will be our web component, which will be the config and JSON, setup that will generate such a component. So that when we say web component, it's the Octant version of a web component, which may be implemented as a browser web component, or it may not be. It's to be determined. We don't even know what that is going to look like yet. It may also be something where we just allow you to, we may say something like you can do Angular components, and you register Angular components, and that's what we support, right? We don't support freeform, whatever JavaScript library you want components. We support Angular components or something like that. So we'll figure that out as we go along. The next thing is the Electron application. This is something that has been sitting there for a while, kind of gathering some dust. We talked about it, and we really do want to invest in fixing and adding the features we need to make Electron the default runtime for Octant. So you double click it, and you get a nice application. No more proxying the view via the browser. So that will be coming. We're probably going to phase it in. I don't know how we're going to phase that in for the release manager tools like Chocolatey and Brew, because we'd either have to do it as a separate, and Sam might be able to answer this. I don't know if it can install both the UI version and the console version, because initially we're planning to ship both, and then eventually we will just ship the UI one, or the Electron one, I should say. They're both UI. but I don't know how that's going to work in our package managers. I don't know if we'll be able to do that in a nice way.
Yeah, that one's going to be tricky because some of them, like, for example, Brew is meant for command line tools. And then I think Brew Cask is the one is for things that opens up a UI. So some of them we might even have to just end up switching package managers altogether.
Okay.
Same thing with Scoop. So we would probably even just lose support for Scoop altogether. And I think Chocolatey is fairly flexible. Nothing should change there, but we would have to significantly rewrite the PowerShell scripts that pretty much right now just download from GitHub releases, and it might be a little bit more complex.
Okay. Yeah, so we'll be figuring that out, but expect to see that coming, and expect to see some changes. We'll be sure to clearly communicate kind of what the new install steps are and what to expect as we start to roll that out. And then one of the final things on here that we wanted to call out is that we're moving Octant over to Go 1.15, and that will require a reinstallation if you're doing any dev work for Octant. That will require a reinstallation of the tools. There's some new binaries or new versions of binaries that will need to be installed for everything to work successfully. So just wanted to call that out. I think Sam or Scott put that one in there. And finally, so that's did Sam or Scott any questions on that stuff that we just covered there? Or do you want to go in deeper on anything?
No, nothing stands out. I think we probably just need to update the roadmap with this information in the GitHub repo. And I think there's also some tangential things, which doesn't necessarily imply 1.0, things like runtime performance, like speed, or even just adding some of the new layouts that we discussed. It doesn't fit under the umbrella of 1.0, or it doesn't necessarily have to be, but I think there's going to be things that will end up hitting on the way there.
Yeah, I think that's a good call out, actually. And we can touch on some of that quickly right now. I'll just add a line in here on the need for speed. So as Sam mentioned, we discussed speed and specifically that Octant kind of renders stuff a little slow. You know, when you're looking at a large cluster with a lot of resources and you load that overview page, it can take a long time. It can, like, on a very large cluster, I've had it take upwards of 20 seconds where you're just sitting there watching a spinner, and that's not acceptable. And so Brian Lyles did a lot of research in this area, and Sam has done research in this area as well. And what ultimately what they both found at this separately, but they've kind of both landed at the same place, was that our speed issue comes from the front end. The way we render Angular stuff and the way Clarity renders data grids specifically is kind of slow. And a data grid, like an empty data grid, it renders in like 10 milliseconds. But a data grid with data, it instantly jumps up to about 100. And then any other data grids on that page are additive. So if you have 10 data grids on a page that all have content, they all don't render in 100 seconds. It's because they're not being rendered out in like a multi-threaded fashion and then displayed. This one renders, then the next one, then the next one. So you end up with 10 data grids taking, you know, now at 100 milliseconds each, you're at 1,000 milliseconds. So you start to do more data grids with more data, and they can get very, very slow. And so we're looking at some solutions around how to do those faster. There's a couple ideas. And this is interesting. So we did look at the back end just to see like how long it was taking. And when you make these requests to the Kubernetes API, even on a very large cluster, if it's the first time you're making the request, so the informers are just being started and the caches are being warmed and things like that, usually the request, I've yet to see a request, even on a large cluster, unless it was general API slowness, take longer than 5 seconds to get all of the data back to Octant. And then after that 5-second period, there's the draw phase, and that takes 15, 16, 17 seconds. And then once all those caches are warm and we have that set of data, Octant's usually returning the response to the browser in a second, sometimes a little less. And then on small clusters, it's very, very fast. We're talking milliseconds. So the fact that it takes 5 seconds to get all of the data back and then 3 times as long to draw on the page is a problem. So one of the solutions was potentially write our own data grid. That's something we're thinking about. Another one is make it feel faster. Basically, load the data grids empty. So now all 10 data grids take when you load them empty. It's an interesting thing when they load empty. If you put 10 empty data grids on the page, it still draws them in order, but you're 10 milliseconds each. So now it's 100 milliseconds to load 10 data grids. And then you can do it like a set timeout or some type of callback to then load the data into them. Well, since that is happening, since the page is already drawn, you now have this experience where this data grid might propagate first and this one might but you're starting to see the data come in and you're starting to see things render instead of this long wait of nothing, no response. I can't scroll. I don't even know what is about to happen. So that's like one of the short-term options of just like tricking it into feeling a little faster. And then also potentially, this kind of overlaps with writing our own data grid, but moving from data grid to Clarity Table and then implementing 3 features on Clarity Table so just to scope this a little, we know the specific features of data grid that we need, so we can throw all the other ones away and only implement the ones that are important to Octant. And by using the table render engine, and then implementing only those things that we need, we get renders a lot faster. Even tables with data render in the same amount of time as an empty data grid. It is crazy how browsers are so optimized to render that table tag. It is crazy how fast they render that stuff. So anyway, so that's where the speed thing. Did I miss anything on speed stuff, Sam? Cool. Now on to the Q&A. So this one was, what should happen when someone is viewing an object being deleted? So there's a PR currently opened, which is here. It's yeah, here it is. So what this one is doing is, and this will give you some background and then we can go into the discussion. We were talking about this briefly at our stand-up. So right now in Octant, when you delete a resource, what happens is it just kind of redirects you up. There's no, you don't get informed that something has been deleted. You don't get anything like that. You're just redirected up and the thing you were looking at went away. And depending on where you're at in the hierarchy, that redirect up may be up to an overview page, or maybe, so like it can be very jarring. All of a sudden you're looking at this thing and then it gets deleted and now all of a sudden you're staring at an overview and you're like, how did I get here? So the idea is to make that experience a little more gentle and kind of inform the user of what is going on, that the thing is no longer there. And there was some discussion going on back and forth about what should that look like and what would be the most useful. And so that's where we're at right now. So I think, Sam, you might have added this question.
Yeah, and we spoke a little bit earlier today at our internal stand-up, but I can reiterate the information here. So the special case about this one is for pods, where because of the fact that pods generate a new name every time when you're deleting and recreating a new one. Originally, this was motivated by scaling to 0 or viewing a pod that's being scaled to 0. And what ended up happening was I was looking at a pod and it would pretty much delete. And then if I were to restart the service by pinging it, then I'd lose access to the pod. And so we might have to handle that particular case differently. But I think generally, I think the 404 bit should be sufficient for most of our, at least, yeah, for most of the other cases. I think the other one worth investigating is namespace, where if you were viewing or if you were actually in a namespace and that namespace is deleted, where does that bring you back to?
Yep. I'm going to add that on here. I think, and one of the things that I commented was that I think that plugins should have the ability to set that page. And the reason is, I can't type and talk at the same time. The reason is because in the case that Sam is referring to, where you have something like a serverless tool or like Knative that's scaling things down to 0, a Knative plugin could implement a not found handler for pods, and then it would be able to get that. It would be able to know that, okay, this pod that came in, or maybe it wouldn't be. I don't know, because the pod is gone, right? So I guess it's really like what can it do? Like, and I don't know enough about it, but maybe it could go into the history, like into its eventing, not eventing, logs. What am I? It could find that thing was, events. It could find that thing used to be a part of it. It got scaled down. I know that there's I see the alerts all the time. I just don't know how you would do it in a plugin, but I think it would be possible, right? To say like, I handle this, and then you get a not found for a pod v1, and then you could take the pod name and you could go look up previous pods from a service, like, or maybe you can find it somewhere somehow and know that it had been scaled, and then provide a useful message that says you're viewing a pod for service A, it has been scaled down to 0 due to inactivity, something like that. That would be cool. I don't know how it would be done, but it would be really cool. And I think the 404 page, or not, it's really not 404. It's a not found. It's different. 404 like page, which I think is a good description that Scott was working on. I think is a good first step. It's generally more useful than what we have now, which is redirecting up, and it also, for things that do have a static name or that are likely to have be deleted or recreated, in this example that we're looking at here in the browser, this is a config map, but you create a config map, your pod says, oh, it's wrong, you come, and then you're in some other tool that's it's coming from GitHub or somewhere, and so you go make the commit, you'll see it, depending on the tool you're using, it might delete things and recreate them, and now you'd still be able to see it, right? It would bounce to not found, and then it would come back. So yeah, I think that's useful. I like this change, and I also think Scott did a thing where he put in fun random Octant, so it just fetches a Octant thing from Wikipedia, which I like a lot. It's I like things that do that. So
it's very tasteful. If it were me, I would just rickroll everyone.
Oh yeah, exactly. I'm like, oh, that's professional right there. That's nice. It's caring, and that's it. Any other questions? Anything else anybody wanted to add? All right. Well, thank you, everyone, and have a great rest of the week.